Hey Fixers! In this video we are going to discuss a very interesting Python feature called short circuiting. Okay, many people have already seen it, even advanced coders. Some of them may be able to identify it, so they know the term, but also many of them, even computer scientists, haven't heard of this term at all. Short circuiting, what does it mean? And it's a feature of a lot of programming languages. So not only Python has this feature, but also Java and other languages. And so what is the feature exactly? So say you have a Boolean expression like, so we have an if statement, then a Boolean expression, and if the expression is true, we print something like true, and if the expression is false, then we print something like false, yeah? Something on these lines, okay. And now it's not an efficient code snippet, but it just demonstrates the feature of short circuiting. Okay, and now say we have an OR statement here, yeah? So we have a left operand and a right operand, and we combine them with OR. Okay, and what do we combine? Like maybe we have variable A and variable, and then we do something here, yeah, like B. Okay, and okay, so now what do we store in A? Like we may store 1 is larger than 0. Okay, 1 is larger than 0 is obviously true. Okay, so no matter what B is, yeah, so B can be like 1 equal to 0, right? Which is false. But it doesn't matter because A is already true. So Python goes from left to right through the OR expression, even if there are many OR elements, like here we can have many ORs, OR operators chained after one after another, then it goes from left to right and it checks the leftmost operand. Is it already true? If it is true, then the OR statement will be true, because OR means that at least one argument of the OR operation must be true in order for the whole operation to be true. Okay, and this is already the case here. A is already true. So it doesn't even evaluate the second argument. How can we check this? Let's make it a very silly argument here, which would throw an exception actually, yeah, an error, because you cannot divide by 0. Yeah, if you try, let's open a shell. Okay, so let's open a shell. Okay, so we try 1 divided by 0. It will throw this error, 0 division error. You cannot divide by 0, basically, yes? Okay, so now we are dividing by 0. We have this silly expression, but now if you execute this code, the short circuit optimization in Python won't even execute this code snippet, because it already checked A and found A to be true. So the OR statement will be true no matter what is on the right hand side of this expression. Okay, so let's execute it. You see it executes true without throwing any error, because the second argument is not evaluated here. We already know that the OR statement must be true. Okay, and similarly, if you have an AND statement, and let's make this smaller. 1 is not smaller than 0, so the result is false. If this is already false, then it won't execute the second expression here, yeah? So it should also run through. Yes, it runs through. Okay, you see that short circuiting, basically it skips computation of the of a part of your logical operators, A and OR and AND, and also other operators which you may have, and executes the rest only if it needs to execute it. So it doesn't execute it if it is not needed, in order for it to determine the overall result of the expression. Yeah. So in order to compute the result of the AND operator, and if you know already that the first expression, so the left argument of the AND operator, is already false, then we know that the AND expression must be false no matter what is the right operator, so the right operand is not executed here, the right expression. Okay, that's already it. This is short circuiting. It makes Python more efficient. For example, if you have a function here, do something, and this function may be very complex, in order to, like, I often had this case in my own code bases where I have complicated functions, and if they evaluate to true, then we do something in the if branch, otherwise we don't. And if you have this function, then you can push it to the right of your argument, of your operand list, and which means that it becomes less and less likely in your code to be executed. Yeah. So oftentimes it won't even execute this part because it already knows from the first expression whether the overall result will evaluate to true or false. Okay. So this is effort optimization. So you should always push the more complex functions to the right of your argument list when using the AND or operators. Okay, that's it for today. Hope you liked the video and see you in the next video. Bye.